Today we are working on percent error. As you work through the worksheet, you will probably need a calculator handy, so you might make sure you have that available to you. We're going to do a couple of examples together, then we'll give you a chance to do one, and then we'll check it together, and then you'll have some independent work. Let's look at question number 1. As a result of experimental work, a student finds the density of a liquid to be 0.1369 grams per centimeters cubed. The known density of that liquid is 0.1478 grams per centimeter cubed. What is the percent error of this student's work? So when we're talking about percent error, the first thing we need to do is subtract the two values. In this formula, when we do the subtraction, these are in an absolute value symbol, so it doesn't really matter which order we subtract them in because we are always going to use the positive value. All right, so 0.1478 minus 0.1369. All right, when we subtract that, we get a difference of 0.0109. Now we're going to take this difference and we're going to divide it by the actual amount, or the exact amount. So in this case, that would be the known density. So 0.0109, and we're going to divide it by the known density, 0.1478. So use your calculator, and when we divide that out, we get 0.07374. For these problems, I would use 4 to 5 decimals when we have these longer decimal pieces. All right, so now we have this decimal. We need to change it to a percent. So we're going to take our decimal and we're going to multiply it by 100. So we get a percent of 7.374, so about 7%. Let's look at example 2. After heating a 10-gram sample of potassium chlorate, a student obtains an amount of oxygen calculated to be 3.9 grams. Theoretically, there should be 3.92 grams of oxygen in this amount of potassium chlorate. What is the percent error in this experiment? So we're going to subtract our two values, 3.92 minus 3.90. And that gives us a difference of 0.02. So now we're going to take the difference and we're going to divide it by the actual amount. So that would be here where it says theoretically, it should be 3.92. So we're going to take and divide by 3.92. All right, when we divide 0.02 divided by 3.92, all right, we get a decimal of 0.0051. Then we're going to take our decimal and change it to a percent. 0.0051 times 100. That gives us a percent of 0.51%. All right, teachers, at this point, if you'll pause the video and let the students work through number 3, and then you can play the video and we'll go over it together. All right, let's look at number 3. The melting point of potassium thiosinate determined by a student in the laboratory turned out to be 174.5 degrees Celsius. The accepted value of this melting point is 173.2 degrees Celsius. What is the percent error in this reading? So we're going to subtract our two values, 174.5 minus 173.2, and that gives us a difference of 1.3. Then we're going to take our 1.3 and divide it by the exact amount. So in this case, that would be the accepted value. So 173.2. All right, 1.3 divided by 173.2. All right, so we get 0.0075. Then we're going to take our decimal and change it into a percent and times it by 100. and we get 0.75%. All right, students, at this point you have 2 more questions on the front, and then you have 5 questions on the back of your worksheet that you need to work through, and then your teacher will go over those answers with you.